favorite subject. Yeah. There you go. The Committee on Science, Space, and Technology will come to order. Good morning. I'm going to recognize myself for an opening statement, then the ranking member, the gentlewoman from Texas, will be recognized as well. Today's hearing is on a subject important to our nation and to our world. This is the first hearing of two on space threats to Earth, reviewing U.S. government efforts to track incoming asteroids and meteors. Although many may be only aware of this subject due to recent events, it is actually one as old as our planet. And I'm going to hold up a copy of Time magazine from nearly 20 years ago, where the topic was featured on the cover. Here's Time, Cosmic Crash. This is 20 years ago. I don't know if they were ahead of their time or not, but in any case, the subject has been around for a while. This was actually given to me by a former staff member who I had researched the subject 20 years ago as well. Though the issue has been around for a number of years, there are many questions still to be asked and answered. The range of questions are broad and complex, from how to track an object millions of miles away to how to respond if an asteroid or meteor is headed toward Earth. The two events of Friday, February 15th, the harmless flyby of asteroid 2012 DA-14 and the not-so-harmless impact of a meteor in Russia, are a stark reminder of the need to invest in space science. The asteroid passed just 17,000 miles from Earth, a distance less than the Earth's circumference. 50 years ago, we would have had no way of seeing the asteroid coming, and even so, it was discovered by amateur astronomers. The U.S. has come a long way in its ability to track and characterize asteroids, meteors, comets, and meteorites, but we still have a long way to go. NASA believes it has discovered 93% of the largest asteroids in near-Earth orbit, those 1 kilometer or larger. But what about the other 7% remaining, about 70, or even those smaller than 1 kilometer, estimated to be in the thousands? An asteroid as small as 100 meters could destroy an entire city upon a direct hit. Are we tracking those? The meteor that struck Russia was estimated to be 17 meters and wasn't tracked at all. The smaller they are, the harder they are to spot, and yet they can be life-threatening. The broad scope of our efforts include participation of governments, research institutions, industries, and amateur astronomers in their backyard or on home computers. Some space challenges require innovation, commitment, and diligence. This is one of them. And this committee will strive to continue to lead in this area. For all of the attention and publicity the two events of February 15th received, it was still too late for us to have acted to change the course of the incoming objects. We are in the same position today and for the foreseeable future unless we take actions now that improve our means of detection. Part of our discussion today is about how to achieve this in the current budget environment. I do not believe that NASA is going to somehow defy budget gravity and get an increase when everyone else is getting cuts. But we need to find ways to prioritize NASA's projects and squeeze as much productivity as we can out of the funds we have. Examining and exploring ways to protect the Earth from asteroids and meteors is a priority for the American people and should be a priority for NASA. We were fortunate that the events of last month were simply an interesting coincidence rather than a catastrophe. However, we still need to make investments and improvements in our capability to anticipate what may occur decades from now or tomorrow. And that concludes my opening statement, and the gentlewoman from Texas, Ms. Johnson, is recognized for hers.
Thank you very much, Mr. Chairman, and good morning. I'd like to welcome each of our witnesses today to today's hearing, and I'd like to thank you for your patience as we postponed this hearing a couple of weeks ago. As the chairman has indicated, this hearing was called in response to recent events in which a large meteor unexpectedly exploded in the sky over Russia, damaging property and injuring people at almost the same time that a small asteroid passed less than 18,000 miles from Earth's surface. While scientists indicate that those two events apparently were unrelated, they both serve as evidence that we live in an active solar system with potentially hazardous objects passing through our neighborhoods with surprising frequency. Indeed, there is increasing scientific evidence that impacts by large asteroids and comets have had profound consequences for life on Earth at various times in the past, even contributing to mass extinctions. While such incidents are very rare, they obviously can cause untold damage and are not something we want to happen, and if we can avoid it. I think it is our increased scientific understanding of near-Earth objects and their potential impact, the Earth, that has had Congress to take this subject seriously in recent years. In that regard, this committee has taken leadership roles on these issues dating back to the efforts of former Chairman George Brown Jr. in the early 90s, a time when references to killer asteroids could still lead to giggles and eye-rolling. Since then, members on both sides of the aisle, including Representative Rohrabacher, former Chairman Hall, and former Giffords, have taken an active and productive interest in this topic, and progress has been made. I hope that today's hearing will provide us with a good update on the federal government's efforts to detect, monitor, and potentially mitigate such hazardous near-Earth objects. Much has been accomplished over the last decade, and I look forward to hearing about those efforts. In addition, I'd like to know if there are additional steps that we should be taking as a country, whether an expanded detection program or international collaborations or other such measures. Well, we have much to discuss today and distinguished panel of witnesses to help us in the oversight. I look forward to hearing from each of you. At this point, I'd like to yield the remaining part of my time to Ms. Edwards, the ranking member of the Space Subcommittee, for her comments.
Thank you, Madam Chairwoman, and thank you, Mr. Chairman. I just wanted to note for the record, Madam Chairwoman, that this hearing is part one of the committee's examination of activities related to near-Earth objects. Subcommittee Chairman Palazzo and I will hold a hearing of part two in early April, and so this will be a continuation. And I wanted to note for the record, Madam Chairwoman, that just a month ago, after the events that made the news, my colleague Rush Holt, who's a physicist here in Congress and former assistant director of the Princeton Plasma Physics Laboratory, and I co-authored an op-ed that appeared in the Washington Post on February 15th, trying to put into plain language what the challenges are, the research challenges, what the threats are, so that the American people have some understanding that, as both the chairwoman and the ranking member and the chairman have noted, is not new for this committee, but poses challenges for the American people, especially when it comes to resources. I think it's very fitting that the committee is considering U.S. government agency roles and responsibilities in near-Earth object detection, tracking, and mitigation, not only because of recent events, but because we've been at the forefront in setting U.S. policy on near-Earth objects for the past 2 decades. And it was this committee that formulated the provisions in 2008 NASA authorization and subsequent policy direction that called for the Office of Science and Technology Policy to develop policies on emergency response and to recommend a lead agency for protecting the United States. And this depended on NASA, who we always seem to call for 9/11 assistance in all space matters, is in stark contrast to the across-the-board cuts that NASA programs now face under law. And so, Mr. Chairman, I'm struck by how this complex planetary protection issue is and how much farther we need to go, and I'm looking forward to today's testimony, and with that, I yield.
Thank you, Ms. Johnson. Thanks, Ms. Edwards. Without objection, other members' opening statements will be made a part of the record. Our first witness is the Honorable John P. Holden. Mr. Holdren serves as the Director of the Office of Science and Technology Policy, the Assistant to the President for Science and Technology, and co-chair of the President's Council of Advisors on Science and Technology. Prior to his current appointment, he was a professor in both the Kennedy School of Government and the Department of Earth Science at Harvard. Mr. Holdren graduated from MIT with degrees in aerospace engineering and theoretical plasma physics. General William L. Shelton is the commander of the United States Air Force Space Command. Prior to assuming his current position, General Shelton was the Assistant Vice Chief of Staff and the Director of the Air Staff at the Pentagon. He currently organizes, equips, trains, and maintains mission-ready space and cyberspace forces and capabilities for the North American Aerospace Defense Command and U.S. Strategic Command. General Shelton graduated from the U.S. Air Force Academy with a bachelor's degree in astronautical engineering. He also holds a master's degree in this field from the U.S. Air Force Institute of Technology. Our final witness is the Honorable Charles F. Bolden, Jr., the Administrator of the National Aeronautics and Space Administration. Administrator Bolden served as a pilot in the Marine Corps, eventually earning the rank of general. In the course of his military career, he participated in several international campaigns. He also tested a variety of ground-attacked aircraft until his selection as an astronaut candidate in 1980. Administrator Bolden held a number of positions at NASA. He was able to participate in and support several space shuttle flights, and he traveled to orbit 4 times aboard the space shuttle, twice as a mission commander. For his many achievements, Administrator Bolden was inducted into the U.S. Astronaut Hall of Fame in May of 2006. He earned a bachelor's degree in electrical science from the U.S. Naval Academy and a master's degree in systems management from the University of Southern California. We welcome you all. Thank you for being here. And Director Holdren, if you'll begin.
Chairman Smith, Ranking Member Johnson, members of the committee, I'm pleased to be here today to discuss U.S. activities to detect, to track, to characterize near-Earth objects, or NEOs, and to develop the capability to deflect any of dangerous size that are discovered to be on a collision course with the Earth. This is, of course, a particularly timely topic for reasons that all of you mentioned in your opening statement. Near-Earth objects are defined as those whose orbits bring them within about 31 million miles of the Earth, a third of the distance to the Sun, some of them traveling close enough to make an eventual collision a possibility. Those with maximum physical dimension of more than a meter are generally referred to as either asteroids or comets, while smaller objects are referred to as meteoroids. All are called meteors upon fiery transit of the Earth's atmosphere, and the pieces that strike the surface are called meteorites. Dozens of asteroids a meter or more in size enter the Earth's atmosphere each year, of which only one on the average is as big as 4 meters. Asteroids of these sizes burn up harmlessly high in the atmosphere. Damage on Earth's surface is likely only when the kinetic energy of the object is in the range of a few hundreds of kilotons of TNT equivalent or above. That corresponds at typical closing velocities to a stony asteroid about 15 meters in equivalent diameter. The 17-meter asteroid that blew up over Russia on February 15th released about 440 kilotons of energy. Asteroids with that much energy strike the Earth only every 100 years or so. Larger events, like the 1908 asteroid explosion over Siberia, which released about 15 megatons of energy and leveled trees over an area of more than 850 square miles, are believed to be once-in-a-thousand-year events. If an asteroid explosion of that size were to occur over an urban area, it could cause hundreds of thousands of casualties. But the probability of this occurring is much smaller than the 1-in-1,000-year probability I just mentioned for one hitting the Earth at all, and that is because land covers only 30% of the area of the Earth, and urbanized areas cover only 2 to 3% of the land area. As a result, the odds of a near-Earth object strike causing massive casualties and destruction of infrastructure are very small, but the potential consequences of such an event are so large that it makes sense to take the risk seriously. Both the Congress and recent administrations have done so. In 1998, Congress tasked NASA with locating within 10 years at least 90% of all NEOs with a diameter of 1 kilometer or greater, those with the potential to threaten civilization. And in 2005, Congress directed NASA to detect, track, catalog, and characterize 90% of all NEOs with a diameter of 140 meters or greater by 2020. The 1 kilometer goal was achieved in 2011. The task of detecting 90% of NEOs larger than 140 meters is much more challenging, but work on it is proceeding apace. More recent legislation directed the Office of Science and Technology Policy to develop a policy for notifying relevant authorities of an impending threat, to recommend a federal entity responsible for protecting the nation from an expected NEO collision, and to implement a policy of threat notification. In an October 2010 letter to this committee, I reported on our progress on those tasks. The budget for NASA's Near-Earth Object Observation Program has actually increased about fivefold since 2009, from a little less than $4 million to $20.5 million in FY 2012. Beyond detection and tracking of potentially threatening objects, moreover, the administration is committed to exploring and developing the capabilities necessary to protect the Earth in general and the United States in particular from NEO threats. NASA coordinates this work with the Departments of Defense, State, and Homeland Security, including the latter's Federal Emergency Management Agency. I thank the committee for its continued support and its interest in this issue, and I'll be pleased to take any questions that the members may have.
Thank you, Dr. Holdren. General Shelton.
Mr. Chairman, Representative Johnson, and distinguished members of the committee, it's an honor to appear before you today. It's also a privilege to appear with my colleagues and teammates in the space community. Space situational awareness underpins our entire spectrum of space activities, and Air Force Space Command is proud of our crucial role in monitoring activity in the space domain. Specifically, we provide capabilities employed ultimately by United States Strategic Command to detect, track, identify, and characterize human-made objects in Earth orbit. Our sensors also are capable of detecting natural phenomena like bolides. However, the nation's current capability to track asteroids is dependent upon NASA and other organizations such as the Massachusetts Institute of Technology's Lincoln Laboratory. For example, during the recent asteroid 2012 DA-14 event, the Joint Space Operations Center at Vandenberg Air Force Base in California used tracking data from NASA's Near-Earth Object Program Office at the Jet Propulsion Laboratory to perform collision avoidance screenings to ensure the safety of our satellites. We remain committed to working closely with our partners to ensure comprehensive space situational awareness for the nation. I thank you for the opportunity to appear before you, and I look forward to your questions.
Thank you, General Shelton. Administrator Bolden.
Mr. Chairman and members of the committee, thank you for the opportunity also to appear today to discuss the topic of near-Earth orbits. And before I formally begin, Mr. Chairman, I'd like to congratulate you on your appointment as the new chairman of the House Science, Space, and Technology Committee, and I look forward to working with you in that capacity. I'd also like to thank you, Mr. Chairman, and Congresswoman Edwards and Congressman Holt, who is not here, for the recent op-eds that you wrote that called more attention to this for the American public, which I think is really important. The events of February 15th, 2013 were a stark reminder of why NASA has for years devoted a great deal of attention to near-Earth objects and why this hearing is so timely and important. The events of February 15th also highlight the wisdom of Congress, the administration, and NASA in enabling a human exploration of an asteroid. The predicted close approach of a small asteroid called 2012 DA-14 and the unpredicted entry and explosion of a very small asteroid about 15 miles above Russia that Dr. Holdren talked about earlier have focused a great deal of public attention on the necessity of tracking asteroids and other near-Earth objects and protecting our planet from them, something this committee and NASA have been working on for over 15 years. Again, NASA has been focused on tracking asteroids and protecting our home planet from them well before these recent events. In fact, NASA's focus in this area is evident from our fivefold increase in near-Earth object budget since 2010. And literally dozens of people are involved with some aspect of our NEO research across NASA and its field centers. In addition to the resources NASA puts into understanding asteroids, the agency partners with university astronomers, space science institutes, and other agencies across the country that are working to track and better understand these near-Earth objects, often with grants, interagency transfers, and other contracts from NASA. The new public attention is not hard to understand. The coincidence of having these two very rare events happening on the same day, along with the unfortunate injuries of over 1,000 people on the ground in Russia, made this a very big news event. However, we should remember that the probability of any sizable NEO impacting the Earth anytime in the next 100 years is extremely remote. To put these two recent evidence in context, very small objects enter the Earth's atmosphere all the time. Current estimates are that on average, about 80 tons of material in the form of dust grains and small meteoroids enter the Earth's atmosphere every single day. Objects the size of a basketball arrive once a day, and objects as large as a car arrive about once per week. Our Earth's atmosphere protects us from these small objects, so nearly all are destroyed before hitting the ground and pose no threat to life here on Earth. However, the potential consequences of a significant impact are potentially very great indeed. Consistent with NASA's role as established by Congress and prescribed in the President's National Space Policy, NASA has taken a leadership role to pursue capabilities to detect, track, and characterize near-Earth objects to reduce the risk of harm to humans from an unexpected impact on our planet. NASA is also developing new vehicles and capabilities, including Orion and the Multi-Purpose Crew Vehicle and the Space Launch System, which will enable human exploration of the solar system beyond low Earth orbit. As the President stated in his April 15, 2010 speech at the Kennedy Space Center, NASA's intention is to, I quote, send astronauts to an asteroid for the first time in history, unquote, and NASA is working to accomplish this mission by 2025. In fact, NASA leads the world in the detection and characterization of NEOs and is responsible for the discovery of about 98% of all known NEOs. Now here I'll take a risk. There should be a chart coming up very soon. It is, thank you. As shown in this graphic, the cumulative discovery of near-Earth asteroids started picking up dramatically in 1998 with the start of NASA's Space Guard search program. And the number of known near-Earth asteroids has grown from a few hundred to nearly 10,000 in just 15 years. And I think it's not insignificant that it goes almost asymptotic when you look at 2005, when the Congress, NASA, and the administration really picked up the emphasis on that. NASA continues to make progress toward the goals set for us by the Congress. To date, over 9,600 near-Earth asteroids of all sizes have been found. Larger asteroids pose a greater threat to the planet as a whole, and the percentage of asteroids we have identified tracks this relationship. We found 95% of the largest NEOs over 1 kilometer in size. Our current estimate is that we have also found about 60% of the NEOs that are between 300 meters and 1 kilometer. As the graphic shows, we still have some work to do to find NEOs in the 140 meter class. And the next graphic, please. You can see here the total discovered per size, and you can see where we're lacking as the sizes go down. Our remote ground-based observations of comets and asteroids have been augmented by close-up reconnaissance data from our science missions. From 1997 to 2001, NASA's Near-Earth Asteroid Rendezvous flyby flew by 2 main asteroid belts before orbiting and landing on the near-Earth asteroid 433 Eros. Last August, our Dawn spacecraft departed the asteroid Vesta and is now on its way to a 2015 rendezvous with Ceres, the solar system's largest asteroid. Launching in 2016, NASA's OSIRIS-REx mission will return a sample of up to 2.2 pounds from an asteroid to Earth in 2023. Of course, NASA is working to accomplish an astronaut visit to an asteroid by 2025. This mission and the vital precursor activities that will be necessary to ensure its success should result in additional insight into the nature and composition of NEOs and will increase our capability to approach and interact with asteroids. NASA has a long history of observing comets and asteroids, but as their importance as potentially hazardous objects has become apparent, NASA has significantly increased its program of detection, reconnaissance, and characterization. We've gained a nearly complete understanding of the population of NEOs over 1 kilometer in size, and we're making marked progress in assessing the risk to our planet from smaller but still dangerous objects. While we emphasize that the risks from impacts are remote, we remain absolutely committed to fulfilling our responsibility to find and track near-Earth objects. We'll continue to scan the skies and update the Congress and the world on what we find. Again, thank you very much for the opportunity to testify today, and I look forward to responding to any questions you may have.
Thank you, Administrator Bolden. Recognize myself for questions, and let me address the first one to Dr. Holdren and then perhaps Administrator Bolden to you as well. There seems to be general agreement based upon your testimonies that we are able to detect 90 to 95% of the near-Earth objects that are larger than 1 kilometer, somewhere around 60% of the objects that are over 300 meters. So my question is this: I haven't heard yet, nor have I seen yet, what percentage of the near-Earth objects, the incoming asteroids that are 100 meters, or what percentage of those objects are we able to detect? 100 meters being, I think, Dr. Holdren, you described in your written testimony as the size of a city destroyer. So what percentage of the 100-meter near-Earth objects can we detect? And do you have a figure for that?
Yeah, at this point, I believe at this point that number would be a little under 10%. The number for 140 meters and above is 10%. The 100 would be a little under 10%.
Less than 10%. And Administrator Bolden, you agree with that?
Yes, sir. And that was on that second chart I showed, where it looks like the less than 10% for anything.
Okay. How many objects are we talking about that we are not able to detect that might be the city destroyers?
Numbers of objects?
Yes.
Mr. Chairman, I don't know that answer, and I that's one thing I cannot take for the record because.
Okay, well, what was the 10% of?
I can answer that question.
Okay, Dr. Holdren.
Chairman, the estimates of how many objects exist, near-Earth objects, in the range of 140 meters or above, are between 13,000 and 20,000 objects. And so that's the number of which we've detected 10%.
Right.
That is the much more challenging goal which the Congress put before us, so to identify 90% of those by 2020.
Roughly 2,000 objects that are city destroyers we are not detecting. Is that roughly right?
No, more.
More,
because the number we're detecting is 10%
of 13 to 20,000.
13 to 20,000.
I was going in.
So you're going the other way. Unfortunately, the number undetected.
I was going 1,300 to 2,000, and I was going to the larger figure. That's why I said 2,000.
So the number of undetected potential city killers is very large. It's in the range of 10,000 or more. 10,000 more. Okay. Not reassuring, but what is reassuring, we hope, is the unlikelihood that one of those city destroyers would actually hit a city. As you pointed out, 2 to 3% of the Earth's area is urban area. Okay, thank you. Administrator Bolden, what programs, what improvements, what developments can we expect in the next, say, 2 years or 5 years to be able to better detect these thousands of near-Earth objects that might be life-threatening?
Mr. Chairman, we continue our work, our collaboration with our international partners. That is very important. As Dr. Holdren mentioned earlier, he didn't specify, but it was a Spanish astronomer who, amateur astronomer actually, or I think you did.
Do you expect improvements in Earth-based satellite, telescopes, for example, that will enable us to better detect these?
What we are really looking at is not improvements, but increase in the numbers of spaceborne assets. We really need to have spaceborne assets that are able to look. We are cooperating right now with a Space Act agreement with a private company called B612 that will be engaged in the identification and characterization of asteroids, and my hope is that there will be more.
Okay, and what percentage of these thousands would we be able to detect in the next few years that we are not detecting now? Any idea?
If you talk about the 140-meter class, our estimate right now is at the present budget levels. That's present budget levels, not the going down budget levels. It will be 2030 before we're able to reach the 90% level as prescribed by Congress to detect and characterize those 90% of the 140-meter class.
Okay. Thank you for the answer, though. Again, that's not particularly reassuring. Maybe we can help you out with the budget. Don't know. General Shelton, last question for you. Was the Department of Defense aware of the meteor that exploded over Russia?
Mr. Chairman, not until we were tipped off by NASA.
And that was after the fact, or how far before the fact?
No, it was. I want to say it was 2 or 3 days preceding.
2 or 3 days before it exploded over Russia. Okay.
I'm sorry, you said the explosion. I was talking about DA-14.
No, I'm talking about the meteor
No.
that exploded over Russia.
We had no insight in that at all.
Even with satellites, even with everything else,
We were aware of the event when it occurred,
and not before.
not before.
I just have to ask you, how then are we going to be aware of, say, incoming missiles if we couldn't detect the meteor exploding over Russia?
Now, we did detect it. We were aware of the event.
But at the time of the event,
Yes, sir.
not before.
Yes, sir. And we would have to take that into a different forum to talk in more detail.
Okay. Thank you. And that concludes my questions. The ranking member, Ms. Johnson, is recognized for hers.
Thank you very much. Dr. Holden, in October 2010, the congressional response to the direction in the 2008 NASA Authorization Act described roles and responsibilities for NASA, FEMA, DOD, and state, but it's silent who has the overall responsibility. And I was wondering who in this administration is who has the single responsibility to oversee these other activities of other agencies?
Well, NASA is responsible, has the overarching responsibility for detection and notification. NASA notifies FEMA, they notify the Department of Defense. On the question of mitigation, who would have the responsibility if an asteroid were discovered to be on a collision course? That would depend on the size of the asteroid and the amount of notice we had. For some deflection missions, you would want NASA to be in charge. For other kinds of deflection missions, you would want DOD to be in charge. So it does not make sense from the standpoint of the mitigation mission to specify in advance which agency would do it. But the notification, identification, notification responsibilities are unambiguous.
So when there is mitigation, do all of you come together, or or who takes the lead? What determines who take the lead?
In that event, we would certainly all come together, and we are in fact exercising those kinds of communications. There is actually an exercise coming up in the middle of next month when we will exercise those interactions, communications, and the exercise of responsibilities. There's a workshop actually coming up at the beginning of next month in which those interagency interactions will be further discussed and delineated.
Thank you very much. Thank you, Mr. Chair.
Thank you, Ms. Johnson. The gentleman from California, Mr. Rohrbacher, is recognized for his questions.
Thank you very much, Mr. Chairman. We're talking about space debris and near-Earth objects that are, it seems to me that these two issues are not just American issues. And when we're talking about the cost of all of this, what are we talking about in terms of over a 20-year period, the cost of actually coming up with a system of deflection and the cost of actually making the determination of what's heading in our direction? Dr. Holden, either you have some cost estimates for it?
Mr. Rohrbacher, I can give you an estimate right now of what we do it incrementally. So we believe we have to detect and characterize first, and then concern ourselves, as Dr. Holdren said, with who's going to do the mitigating action or the deflection action. We have two concepts. One is about $750 million for an infrared-based sensor that is placed in space, something that orbits Venus or at least is in geosynchronous orbit. B612 that I mentioned, their estimate for their effort is about $500 million, about $500 million. So we're roughly in that range.
Is that just for that one sensor that we're talking about?
That's just to try to put something in space that will help us to identify and characterize. I think all three of us agree ground-based systems are great, Arecibo and others, but if you really want to find and detect asteroids, near-Earth objects early enough that we can do something, then you want that vehicle to be
and the cost is?
I gave you an example of two. What I will take it for the record to get back to you. I think what you're asking for is a life cycle cost for a program to mitigate. I don't think any of us have We have not developed that.
Well, it's in the billions of dollars, correct?
Oh, yes, sir.
Okay.
If
Now-
one detection device is almost $1 billion.
Now, let me suggest that perhaps the billions of dollars, and that would provide protection for not just the United States, but for the world.
Sir, anything we're talking about, this is not, as you pointed out, this is not an American issue. Anything that we do, it protects the planet. Anything that our international partners do protect the planet, and that's why you hear me talk all the time about the critical importance of international collaboration.
That's what I want to ask you about on this. What steps have we taken to bring countries together that could contribute those billions of dollars as well as our own?
Well, the UN Organization for Peaceful Cooperation of Space, UN COPUOS, has a very active ongoing activity in trying to help bring nations together and looking at detecting and tracking NEOs, and we are a participant in that.
There's not just one organization that is aimed specifically, or when was the last meeting of groups of people who represent countries that might want to get involved and contribute and have an overall plan?
Congressman Rohrabacher, I can take that one. There was a meeting in Vienna in mid-February of this year, just a month ago, under the auspices of the UN Committee on Peaceful Uses of Outer Space. It was agreed there to stand up an international asteroid warning network and to stand up as well an international body that would deal with the mitigation question. There is already underway something called ADA, the Asteroid Impact and Deflection Assessment, which is a joint effort of the European Space Agency and NASA. And I should add that the detection network that we already have is highly international in character. As Administrator Bolden mentioned, it was actually a Spanish observer who first discovered the asteroid that made the near miss on February 15th. The Minor Planet Center, which is in substantial part funded by NASA and hosted by the Harvard-Smithsonian Astrophysical Observatory, is actually under the overall auspices of the International Astronomical Union. So it's all very international.
I would suggest that, number one, the cost of deflection, of course, we're talking about the cost of detection on one situation. The cost of having a deflection system is even more. I would suggest that this is one area of leadership that the United States could really take a role in, and it would be good for all, and it would create an international spirit that what we want to create. I would suggest especially including Russia in on this, and they may be able to make some major contributions and save us some money and actually make it a more effective system. And with that said, I'd like to include all countries except China. Thank you.
Thank you, Mr. Rohrabacher. The gentlewoman from Maryland, Ms. Edwards, is recognized.
Thank you, Mr. Chairman. I want to ask Dr. Holdren, the National Science Foundation has indicated a next major new start as the Large Synoptic Survey Telescope, the LSST, which is intended to detect and catalog potentially hazardous objects. And what I'd like to know is, one, what the technological contribution would be if the LSST were to make the overall detection and cataloging effort possible. And Dr. Bolden, General Bolden, you talked about the prospect of, a land-based systems versus systems that we would put outside in our solar system, but the cost to me, it seems, would be rather significantly different. And then I'd like to have some understanding of whether there might be some cost sharing that NASA might consider with improvements to the LSST to try to optimize it for NASA's use, and get a sense as well of whether the challenges that we're facing in not meeting the 2025 deadline, that guideline that we've highlighted from the committee, are those technological challenges principally? Are they funding challenges? Is it some combination of cooperation challenges. I'd like to better understand that, especially in this fiscal environment.
Well, let me just make a start, and then I'll turn it over to Administrator Bolden. The Large Synoptic Survey Telescope would be an important addition to our capabilities, but it's important to understand that all these capabilities work in tandem. That is, they share information. Some of the telescopes are better at detection, others are better at characterizing the orbit or determining the reflectivity and the likely composition of the object. And so one always has to think of this as a network. We have telescopes in Arizona, we have telescopes in Italy, we have telescopes in the Czech Republic, and they're all linked together, and they're all part of a network that provides the overall capability we have to detect these objects. The LSST alone, when it comes fully to fruition, would still not be able to enable us to identify and characterize 90+% of the objects in less than about a dozen years. But in combination, the LSST and an orbiting infrared telescope of the kind Administrator Bolden was talking about could lower that time to something in the range of 6 to 8 years.
Congressman, the only thing I will add, we flew an infrared imaging satellite called WISE, and then we repurposed it while on orbit to look for asteroids, and we discovered hundreds in the deep field of the solar system, the universe, actually. It is that type of instrument that I talk about. That's what B612 wants to do. We are looking at ways to cost share. The nucleus organization that Congressman Rohrabacher mentioned involving Russia, the 5 member organizations of what we call the International Space Station team, and that's 15+ European nations, Russia, Japan, Canada, and the United States. Although our primary responsibility is operating the International Space Station, when the heads of agency get together, we talk about everything. And one of the big things we talk about is the threat of near-Earth asteroids. At risk of getting in trouble, because the Congressman Rohrabacher and I have a healthy agreement to disagree, and I will say this, it will be the decision of this Congress as to whether or not we ever cooperate or participate with China. It's the elephant in the room. I don't talk about it because my public affairs and communications people tell me not to talk about it. But I don't deal with China by direction of this Congress. It is, we are the only agency of the federal government that does not have bilateral communications with China. This is an issue for the world. This is not an issue for the United States. So, although Congressman Rohrabacher and I,
well, I'll let Congressman Rohrabacher take his time talking about China, and I'm sure we could have a whole hearing on it. Before we go, though, I wanted General Bolden to, the whole identified mission that the President has set out to go to an asteroid, it seems rather lackluster, and so I've always had questions about whether that ought to be a goal or we ought to think about sort of the trade-off Mars instead. Thank you.
Thank you, Ms. Edwards. The gentleman from Texas, Mr. Hall, Chairman Emeritus, is recognized for his questions.
Mr. Chairman, of course I thank you, as we all do, for holding this very important hearing, and I thank the witnesses for their very valuable testimony. I had the privilege of serving on this committee since 1981. And this topic has been the subject of periodic review and legislative direction, as the witnesses noticed. In the 90s, during consideration of a NASA authorization bill, this matter came up, and it was really a discussion about asteroids. We had really a hearing on asteroids, as Mr. Rohrabacher remembers. And it was reported at that time that one had just passed the Earth that no one knew anything about, but it missed us by 15 minutes. I hated to ask, was that just as good as it missing us by 1 minute or 30 seconds or what? But just the enormity of the damage that they could do to us. I offered an amendment at that time to set a goal of finding and cataloging within 10 years this population of comets and asteroids, an effort to be coordinated with the Department of Defense and space agencies of other countries. Other countries were invited to that hearing, but also told that we ought to have a world group because, as Charlie said, it's a world problem. They were interested in attending, but they weren't interested in contributing anything to it, so none of them showed up for the hearing. But as our witnesses stated, from 1998 until 2011, more than 90% of near-Earth objects with a diameter 1 kilometer or greater have been located. So today we know more about these, but we also have more work to do, especially those that are smaller that could still have a devastating impact if they hit the Earth. So, Dr. Shelton, let me ask you this. What capabilities do we need that we don't currently possess to detect and track asteroids that might pose a threat to the Earth?
Sir, if you're talking about Department of Defense
What
capabilities...
do we have to do? What should we do?
Well, if you're talking about Department of Defense capabilities, we are focused on things in Earth orbit. Our sensors, and we've got a variety of them, are not focused on beyond the Earth.
Well, once an object's been identified, what are our means of tracking it, and how much time would we have to prepare if there were a threat to the Earth?
Maybe I can take that, Congressman Hall.
Okay.
First of all, how much notice we have depends on the size of the object. The bigger it is, the further away we can see it, and the more time we have. So there's some objects that we know are coming years in advance. There are other objects that are still big enough to cause damage that we only know about weeks in advance or days in advance. Obviously, we need to improve the capability to give us a large amount of notice, enough notice to mount a deflection mission if we see one on a collision course. Some of the capabilities we've been talking about, the Large Synoptic Survey Telescope, the orbiting telescope that the B612 Foundation is working with NASA to develop, all those capabilities will increase the warning time with respect to asteroids big enough to do serious damage. And again, the deflection options that would then be open to us would depend on the size of the object and the amount of notice we had. They would include...
Well, excuse me, the one that hit Russia, there's no question about that, and that's about all we know about it. Why didn't we know that was coming, that was in the area or on its way?
It came out of the sun, Congressman Hall. It came from a direction where our telescopes could not look. We cannot look into the sun.
Well, we can't make that determination as to where it's going to come from. We ought to be able to do something no matter where it comes from if it's going to hit the Earth.
That is one of the reasons that an orbiting telescope
That's why we have this hearing today. Ask you three men who know a heck of a lot more than we know about it to tell us.
Well, I would say, Congressman Hall, that the most important single thing we could do to improve our capacity to see any asteroid of potentially damaging size coming would be an orbiting infrared telescope of the sort that the B612 Foundation is working on.
I asked the question, well, if we saw one coming toward Omaha, what could they do about it? And they said they could use a laser. And I went on and asked the second question. I said, well, could the laser hit it right in the middle? And because I didn't want to cause any more trouble than I had with Mr. Lorbacher, I wasn't going to suggest that half of it hit Los Angeles and the other half hit New York. I suggested it might half of it go to the Pacific Ocean and the other half go to the Atlantic Ocean. They didn't really have an answer for that, and I doubt if you have.
Well, first of all, it would not be practical to have a laser powerful enough to split it in half. What you can do in principle, if you have a very powerful laser, is to cause jets of material heated by the laser to fly off of the asteroid, and that is essentially the equivalent of a jet engine pushing the asteroid off course. There are other approaches to deflecting an asteroid. Those include hitting it with a very heavy impactor. They include approaching it, as we've already approached with robotic probes, a number of asteroids,
I thank
and
you.
pushing it or
I'll
towing it.
write you a letter for some more, and thank you. I'll yield back my time at it.
Okay. Thank you, Mr. Hall. Those were interesting answers, Dr. Holdren. Appreciate that. The gentlewoman from Oregon, Ms. Bonamici.
Thank you very much, Mr. Chairman, and thank you all for your interesting testimony. It's been well established in this testimony that the probability of an occurrence of a sizable NEO colliding with the Earth is quite small. I believe, General Bolden, you said extremely remote in your testimony. But it's also clear that the consequences could be enormous. For example, a strike, depending on the size of an asteroid, could bring a cloud of dust rivaling the most powerful volcanic explosion, or depending on where it hits, could cause an enormous tsunami that would flood and destroy coastal regions. And I know you're all striving, as we are, to find the appropriate balance for investment without being unnecessarily alarmist. In the district, back to where it hits, in the district I represent in Oregon, it's a significant threat of a tsunami, especially from earthquakes. That's a very real. Response preparedness is already a priority issue for my constituents. In fact, when I was in the legislature, we passed a bill that required the state to plan for the impacts of a 9.0 magnitude earthquake and a resulting tsunami, which scientists had determined will occur at some point in the future. So it's not planning for if, it's planning for when. And the state just released its resilience plan, which was partially funded through a FEMA grant in February. The plan acknowledges the importance of preparing communities and infrastructure for a catastrophic event, but it also places a significant focus on the ability to respond once the event has occurred. And of course, this type of challenge has implications in the context of today's conversation. How much do we plan for detection? How much do we plan for response? Of course, we should be investing in the science that will help us detect and prevent the impacts of NEOs, but we also need to consider how we will respond if it's not possible to alter the orbits and stop these NEOs from colliding. Dr. Holdren, your 2010 report indicates that depending on the projected damage and location, FEMA could help provide federal assistance and coordinate local emergency services personnel into integrated disaster response task forces. So could you talk a little bit more, please, about how FEMA is approaching this role? How will they take into account different demographic and geographic characteristics in any given area? Thank you.
Wow, that is a really challenging question. As we know, FEMA has a wide range of capabilities for responding to a wide variety of different kinds of emergencies and disasters. We are in the process, as I mentioned, of conducting exercises of various kinds in which FEMA is a participant and thinking about and trying to work out the details of response strategies depending on the nature of the impact. But as your question points out, those impacts could be very different. If a large asteroid strikes the ocean, as you point out, the impacts would largely come through the tsunami phenomenon, which is, of course, a phenomenon with which FEMA must also reckon, since tsunamis can be caused in other ways. If a strike occurred over an urban region with sufficient force, the damage would resemble in some ways the damage from a massive earthquake, which is another event with which FEMA is familiar and prepared to respond. But these are going to be big challenges. I would not minimize the difficulty of responding adequately if a substantial asteroid strike should occur in the size range that we need to be particularly worried about.
And so what efforts are being made to engage the existing emergency response infrastructure?
Well, as I say, we are actually exercising those with tabletop exercises and with larger scale exercises in which the various agencies go through a simulated event of this kind. And those kinds of exercises are really the best way we have, when combined with analytical tools, to figure out how to bring our capabilities effectively to bear.
Thank you very much. And either General Bolden or General Shelton, do you have any comments about finding that balance between preparing for detection and preparing for how we respond?
Congresswoman, I would just echo what you said. You hit the right word, and that's balance. We could come out of this hearing and decide that we want to really pour money into NEO detection and characterization, and that would not be the right thing to do, because there has to be a balance. My recommendation would be the President's budget from 2013, I think, was pretty good. And we have a plan that Dr. Holdren talked about, but it depends on the passage of that budget. Going into 2014, we will come back again and try to give you what we see as a funding level to support the plan that Dr. Holdren addresses. So that's where we have to cooperate, Congress and administration, in striking that proper balance.
Thank you very much. My time has expired. I yield back. Thank you, Mr. Chair.
Thank you, Ms. Bonamici. The gentleman from Alabama, Mr. Brooks, is recognized.
Thank you, Mr. Chairman. Reading from Dr. Holdren's testimony, says, quote, depending on its composition and velocity, an asteroid of 140 meters in diameter could have an impact energy in the range of 50 to 500 megatons of TNT equivalent and would be capable of causing destruction over a large region. Emphasis there, 50 to 500 megatons, and I've got other notes here that suggest that the Hiroshima atomic bomb was roughly 13 kilotons, so much, 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 much smaller. If you could you please describe with greater detail what you mean by a, quote, large region, end quote?
The size you're talking about, 140 meters, and you've got the numbers exactly right, could devastate the better part of a continent.
We're talking about a very large region.
The only fortunate thing is that the estimated frequency with which objects of that size strike the Earth is about 1 in 20,000 years, or a probability of 1 in 20,000 each year. Nonetheless, this falls directly in the category that we were talking about, low probability, very high consequence. Therefore, we need to take the risk seriously, and we need to make the kinds of investments that would enable us to deflect an asteroid of that size were one to be discovered on a collision course.
And you also use the word destruction. In the context of this continent-sized area, would human life be able to withstand that kind of impact in the way in which you use the word destruction?
Well, clearly, if an asteroid of that size struck on land, there would be a very large loss of life. If it struck in the ocean, it would produce, in all likelihood, a very large tsunami, which would be associated with large loss of life. If you say, would humans survive on the Earth, the likelihood is yes. But there are concerns about the amount of dust and smoke that could be lofted into the atmosphere by such an impact.
Do you have a judgment as to whether humans would survive on the continent impacted, if you limited it just to the impact continent?
No, I believe the answer is yes. I said a substantial part of a continent. A bigger one, bigger still than 140 meters, could be a continent destroyer, and a bigger one still could be a civilization destroyer. You know, the one that hit 65 million years ago near what is now the Yucatan Peninsula is thought to have led to the extinction of the dinosaurs and most else that lived on Earth at the time.
And if I read your written testimony correctly, that was roughly 10 kilometers estimated size?
Yes.
Moving on, looking at the notes that I've been given by the HASC committee, it suggests that we've identified so far thousands of objects in space, near-Earth objects in space, that are 300 to 500 meters in diameter, roughly 1,100, 1,200 that are roughly 500 to 1,000 meters in diameter, and roughly 900 that are a kilometer or more in diameter. So what I would like to know is, how much advanced warning would the Earth's population need of, say, one of these kilometer or larger size objects for us to be able to do something to prevent that object from hitting the Earth and causing the kind of massive devastation that you have described? Today, we would probably need years to mount such a mission.
over time, as we develop our capabilities to deal with this kind of threat, the lead time could be smaller.
Let me focus in on that. How many years would we need? Let's say we found out today that there's an object of this size that's going to hit the Earth. How many years would we need today if we were to do whatever is necessary to try to put ourselves in position to save the planet?
I think I will refer that question to General Bolden.
Well, if we did it according to the President's budget presently, 2025 is the time that we think, we will be able to send a human to an asteroid, acting with some robotic means. That's on the present plan.
Let me interject for a moment. Let's assume that we know one's going to hit the planet. In which case, I assume that we're going to accelerate things as quickly as we can. What's the fastest we can get it done where we could protect ourselves upon discovery of a 1 kilometer or larger object going to hit the Earth?
Congressman, I will take it for the record to get back to you, but now you're talking about an intense effort, which, that significantly shortens the time.
Well, we would be intense.
We have the systems and the technology available now to do that. You're talking about just pouring unlimited funds into it, and conceivably you could do it in 4 or 5 years. I don't know, but let me get back to you. Don't quote me on a number yet. But I'll work with General Shelton and his captain, and we'll get you an answer.
Well, thank you for being here and testifying before us. Thank you, Mr. Chairman, for the time that you've allotted, and whatever time that is, I'd love to help you shortening it.
Thank you, Mr. Brooks. The gentleman from California, Mr. Swalwell, is recognized for his questions.
Thank you, Mr. Chairman, and thank you, Ranking Member Johnson. General Bolden, I represent Livermore, California, which has 2 of the NNSA labs, Lawrence Livermore and Sandia. And I imagine that when you talk about systems and technology, and if we were to require a weapon to deflect something that was incoming, a near-Earth object that was incoming, that some of that technology will have to be or has been designed at one of those laboratories.
So if that's a question,
yes.
If that were the decision, but again, I would go back to what Dr. Holdren said earlier. I would not consider a weapon, to deflect or to save Earth against this type of threat. I would consider the development of appropriate technologies that could enable us to. We're talking about earliest detection. You're talking about deflecting. It's a tiny amount if you catch it far enough out. And
now let's assume it's late stage detection.
Oh well,
I imagine our choices get limited, right?
Yes, sir. But I don't. That's not my bailiwick anymore. I don't do bombs and rockets and stuff.
Well, General Shelton, those 2 laboratories in my district, I imagine they would play a critical role if we had a late stage detection of one of these near Earth objects.
Yes, sir, I would think so. There are only a limited number of ways to generate the amount of energy required, and probably nuclear energy is what we're talking about here.
Is there a way to guarantee that one of these near-Earth objects does not hit on a Friday? Because right now in my district, all of the federal employees at those laboratories are furloughed on Fridays. And I know in Congresswoman Edwards' district, some of those NASA employees that are trying to detect these incoming objects, I think they're going to be furloughed on Fridays too. So
no, sir.
No way to.
We are not planning to furlough employees. I just wanted to clarify that. So they will be there on Friday.
Okay.
But in seriousness, I have to go back again to say several things. One, these are remote occurrences. 2, the plan that the President has put forward, I think, will adequately address our technical capability to be able to deflect an asteroid in due time. If we find that we are tracking literally thousands of asteroids today. If the civilization destroyer that Dr. Holdren talks about, if we can't discover that early enough, then there's something wrong with our systems. So,
sure. And so in our district, it is a fact. There are furloughs at our nuclear laboratories. And you're not concerned at all that sequestration affects our readiness to protect?
Sir, that wasn't the question you asked.
So my question
I am very concerned with the effects of sequestration, but that wasn't the question. And so, yes, I am very concerned about the effects of sequestration on all of our ability to do what it is you ask us to do. You're talking about impacting our ability to keep our facilities operating safely. You're talking about the mental strain on our employees not knowing whether they're going to be able to come to work tomorrow. I try to assure them every time I can that I'm not planning to furlough anybody, but they know better than I do that the Congress could take some action, and all of a sudden the administrator doesn't have a clue what he's talking about because now I've got to lay people off. My intention is not to do that. If your question is there a bad effect of sequestration? Yes, sir.
That's my question.
Yes, sir.
How about for General Shelton?
I'll tell you, sir, just about my every waking moment these days is based on this topic. I've just pulled the trigger on $508 million of reductions in just my major command alone from now to the end of the fiscal year. 20% cut in pay to my civilians. There are resources that are used for missile warning and missile defense that we won't be able to operate at full capability. There are things that we use for space surveillance that we won't be able to operate at full capability.
In general, do you think that makes us more or less prepared to handle a near-Earth object?
That is not what we do. That is NASA's responsibility. We contribute serendipitously at times, but we are focused on things in Earth orbit.
So if you had to focus on something in Earth orbit, would it make you more or less prepared having to have these across-the-board cuts?
We are clearly less capable under sequestration.
Great. Thank you, Mr. Chair, and I yield back the balance of my time.
Thank you, Mr. Swalwell. The gentleman from Florida, Mr. Posey, is recognized for his question.
Thank you very much, Mr. Chairman, and thank all three of you for your very detailed written testimony. You use a lot of facts that I frequently refer to that clearly indicate it's not a matter of if, but when civilization will be threatened by an impact. Until the recent Russian impact, quite a few people thought those of us who were even aware of this or dared mention it were on the kooky side. And so one good thing about that is maybe a little bit of a wake-up call to reality for some people. Dr. Holdren, your testimony referred to the first ever exercise and deflection exercise. I wonder if you could just share a little bit with us about how that went.
I'm not the first ever deflection exercise was a kinetic impact on an asteroid of medium size, which, while interesting from the standpoint of the deflection it generated, did not reflect the magnitude of the capability you would need for a late notice deflection of an asteroid of threatening size. It was an interesting demonstration.
Okay.
One of the things I'd like to reinforce is that the President's proposal to land U.S. astronauts on an asteroid by 2025 will in fact exercise a number of the capabilities that would be necessary to have in our toolbox should an asteroid of threatening size be detected on a collision course. I would disagree with something Congresswoman Edwards said, that this is a lackadaisical program. I think it is a crucial program, and I think it is. I think it is going to lead to major advances in capabilities which are not just interesting to demonstrate at a small scale, but not enough to deal with a real threat.
Thank you. And I took her comment to mean she thought the approach to it might have been lackadaisical, not that it wasn't necessary in it, you know, for whatever.
For the record, I didn't say that word.
Okay. Now, the ranking member asked about protocol, you know, who's in charge, and we got about 3 or 4 minutes of chatter, but we never got an answer about who's in charge. And so rather than you ask for a response, I would just like to recommend that the next time that y'all come before us, you give us a protocol and say, this is who's in charge here, here's in charge here, and here's in charge here. And it's just a very clear matter of protocol, who's in charge in various instances. You know, to just be preordained and pre-established. I know you're going to cooperate and, you know, get this stuff done if we have an impact, but, you know, a good segment of the population thinks it's just a matter of call Bruce Willis in, you know, and you know, notwithstanding we don't have a shuttle anymore, you know, that's impossible. But things that beg for an answer, you know, scary, of course, that we only know about 10% of the huge threats, and we virtually have no idea of the small threats, like the one that went undetected, the recent impact in Russia. You know, what would we do if you detected even a small one? Like the one that detonated in Russia, headed for New York City in 3 weeks. What would we do? Bend over and what?
No, Congressman, you know, that is, I don't, again, I have to go back to what I said before. These are very rare events. From the information that we have on asteroids that we've discovered of all sizes, we don't know of one that will threaten the population of the United States, you know, in 3 weeks. And we are trying very diligently, as I said before, with the President's budget, to put ourselves in a position where we advance the technology such that 3 weeks will not be something that causes us to panic, because we will be able to respond. We are where we are today because, you know, you all told us to do something, and between the administration and the Congress, the funding to do that did not. The bottom line is always the funding did not come, and I don't care whose fault it is or if it's anybody's fault. We all know what we're facing today. And we're all sitting here today as the Congress and the administration try to figure out sequestration, something that never should have happened, nobody planned to happen, but we're facing it today. And so the answer to you is, if it's coming in 3 weeks, pray. If we find that out right now, and that's not bad.
That's reality.
That's not bad policy, though.
Yeah.
I'm a practicing Episcopalian, and I love what the Pope's doing right now. I'll tell you that things have happened. You got to pray.
The upside, I guess, is that there's more public awareness now of the importance of space to the survival of our species, and it's not at some unknown point in the far distant future that we can't imagine. You know. And
sir, if I may, you say something that is so important. It would be very easy for this Congress and for the administration to say, okay, because we get the question all the time, why are we worried about exploring beyond low Earth orbit? Can't we just put that off for 5 or 10 years? The reason that I can't do anything in the next 3 weeks is because for decades we have put it off for the next 5 or 10 years. We don't have contractors who go away from doing their job and then 5 years from now we call and say, okay, we want to build a rocket. They'll tell me, with whom? We don't do that anymore. All those guys went over and they're now selling pizza. And I'm not being facetious when I say that. And I apologize. You cause me to lose my temper sometimes this is really important.
Yes, it is.
And it has to be continuous. The President has a plan, but that plan is incremental. And we can not like him, we can not agree with him, we can not do a lot of things. It is the best plan we have. And if we want to save the planet, because I think that's what we're talking about, then we have to get together, that side and that side, and decide how we're going to execute that plan as expeditiously as possible. That's all I can tell you.
Thank you.
Thank you, Mr. Posey. The gentleman from California, Mr. Takano.
Thank you, Mr. Chairman. This use of the term civilization threatening or civilization destroying asteroids, let's remind me at what size would we say such an asteroid would be?
A 1 kilometer asteroid would be carrying energy in the range of tens of millions of megatons. That is as much or more energy as was in the combined arsenals of the United States and the Soviet Union at the height of the Cold War. An asteroid of that size, a kilometer or bigger, could plausibly end civilization. Nobody has the detailed models, the ability to calculate in detail to tell you exactly what the threshold is. But when you're talking about tens of millions of megatons of explosive energy, you are putting civilization at risk.
And I'm hearing that we're relatively optimistic that we can develop systems at the right price points to be able to detect asteroids of this size with a sufficient amount of lead time to be able to do something about it.
Well, yes, that's the size range where we've already detected something in the range of 93-94% of the asteroids of that size range that could come close to the Earth. And in that size range, we can be reasonably assured, especially as we make these additional investments going forward, of being able to detect them with quite a lot of notice.
Let's scale it down to medium to large size city-destroying asteroids. What size would those be?
A city-destroying asteroid could be in the range of 50-meter diameter, carrying an energy in the range of 5 to 10 megatons.
What sort of systems would we need to be able to detect that? I mean, you talk about more assets in our orbit, telescopes of that kind, including those that could get around the issue of the sun.
Yeah, we would want the infrared telescope in an orbit resembling that of Venus. It could be a Venus trailing orbit following the planet around, the planet Venus, which again is what the B612 Foundation is in fact working on. As Administrator Bolden mentioned, we actually had an experiment with an infrared telescope that was built for an orbiting telescope built for a different purpose. It's very good at finding asteroids.
We spoke a lot about the cooperative nature of what would need to happen, nations coming together, but would there be also rivalrous kinds of impulses which might divide us? In fact, if we're to detect objects of this size, would nations also be concerned about that impacting the ability to detect missiles, for example?
I think these are very different capabilities. As General Shelton mentioned, going into detail about our missile detecting capabilities would require a different forum, but they are quite different in nature from the capabilities we need to detect and track asteroids.
Well, the chairman raised a question that I thought was rather interesting. Did none of our current missile detecting capabilities, they fail to be able to detect the most recent asteroid? And you may not be able to answer that question here.
I can.
Yeah.
We did detect it. And as I said, it was at the time. It wasn't predictive. It was detection at the time.
So the missile detection capacities we have now, I mean, really are kind of, they're more in real time as opposed to time that we might be able to remediate the problem.
Yes, sir, and focused on two things. The infrared signature coming out the back end of a missile, we see that. And as soon as it either breaks the ground, if there's weather overhead, as soon as it breaks the clouds, we will see that. We'll be able to tell you what type of missile it is. We'll be able to tell you where that missile's going. We'll be able to tell you where it's going to impact. So very solid missile warning capabilities. Those infrared sensors can be used for other things, but they can't be used for predictive things out beyond Earth orbit.
Mr. Chairman, I'm out of time. Thank you so much.
Thank you, Mr. Takano. The gentleman from Arizona, Mr. Schweikert, is recognized.
Thank you, Mr. Chairman. Just because I want to get my head around and try to really understand some of the base level approach here, and Doctor, I was going to ask you first, and forgive me if I'm equating a statement to you that was in someone else's opening statement. A dangerous interaction, Earth and an object. Was the statement one out of 1,000-year event?
The 1 in 1,000-year event is the one of the magnitude that hit over the Tunguska asteroid impact over Siberia in 1908. And that was a 15 megaton class event. That's characteristic of 1 in 1,000 years. The dimension of that asteroid was somewhere in the range of 50 meters.
Now, if I remember my old modeling classes, when you start getting into something with that far out in the tail, you know, it's like the person that says it's a 500-year flood, except we had 3 of them in the last 10 years, because you have such your degree of confidence, your noise in that just becomes it blows off the chart. So we always like to say 1 out of 1,000, but it's 1 out of 1,000 with, you know, a 20% lack of confidence. Does that sort of math also work for this?
Well, I would say certainly there's a lack of confidence of that size or greater, but the real catch is that a 1 in 1,000 year event can occur at any time. The fact that on average one only expects these to happen once in 1,000 years doesn't mean that one won't happen next year.
That's often when we talk to sort of non-statistical people, you try to explain that
right.
Yeah, you can have the 3 500-year floods in 10 years and then go 1,500 years without something. It's okay. In the discovery of objects out there, how much are you finding is coming from the amateur astronomy community? I mean, if I remember correctly, you were telling me that, was it an amateur in Spain that saw the last?
I'm not sure it was an amateur.
I don't know that it was we can find out whether it was an amateur astronomer. We just know it was an astronomer in Spain that made the discovery on 2012 DA-14.
Is there, how formal or informal is that network out there of university, amateurs, governmental, astronomers, scouring the sky, seeing things, reporting them? How does that mechanism work?
It is actually quite organized, quite formal, and quite fast. That community of folks stay in constant communication. Let me take this opportunity to recommend a book, because it's not mine, a book by NASA's head of the Near-Earth Object Identification Program, Dr. Donald Yeomans. Just came out this year, 2013. It's called Near-Earth Objects, Finding Them Before They Find Us. Nice title. And he talks at great length about these networks, about the roles of amateurs, about the roles of professionals, who's discovered what.
You're beating me to where I was actually trying to go. Is there a way to take that network and incentivize it? I have a great interest in sort of distributive information, distributive networks, finding, so lots of smart people all over the world with their hobbies. And is there a way, should we be incentivizing that?
I think that's a great question, and we in OSTP are greatly in favor of crowdsourcing. We're greatly in favor of putting challenges out there, and in fact,
you and I are about to become really good friends.
and these challenges, we already know we've used them across a domain of interesting problems, and I think there's no doubt we're going to have a challenge around asteroid detection.
And it's not answerable in 20-some seconds, but part of that is, okay, we see something. How far in advance with current technology do you have to see something to analyze, determine, threat assessment, and then react to it?
The analysis and threat assessment is pretty fast, because once you see it, you can train on it various other instruments, the radio telescopes, optical telescopes, and use the combination of information available from them, once they know where to look in the sky, to characterize its trajectory and determine whether or not it's a threat. The long time scale, the long pole in the tent, is deploying the capability to deflect one that you discover is on a collision course. And that's the issue where currently we would have to say the time scale is in the range of years. And I think Administrator Bolden suggested that he would get back to the committee on that but I think his initial estimate is certainly reasonable. Even throwing a lot of resources at it, you'd be talking 4 or 5 years to mount a deflection mission.
Mr. Chairman, thank you for your patience.
Okay, thank you, Mr. Schweikert. The gentlewoman from Connecticut, Ms. Estee, is recognized.
Thank you very much, Mr. Chairman. I, too, share some of the interest in this sort of crowdsourcing and would just flag, since we've already had some hearings on big data, to perhaps follow up at a later time to think about what opportunities there are in other areas. We're also looking at the data side and how we might be able to collaborate on this worldwide problem. And I think that's very important. For General Bolden, if you could talk a little bit about what NASA's procedure is for actually notifying our federal agencies. You get notice of a NEO. What do you need to know? What triggers a notification warning? And how does that actually work?
Congresswoman, there are several organizations we notify. We notify the State Department, first of all, because they notify our international partners that there is an incident. And this is not just for asteroids. This would be for a satellite that's fallen back to Earth or something. And we've had to exercise that several times over the last 2 years. The first person I would notify would be Dr. Holdren as the President's science advisor. And going back in response to Mr. Posey's question, there is no question in my mind who's in charge. And it's, I go to Dr. Holdren because he pulls the team together, whether it's DOD and NASA and everyone else. But I understand the thrust of the question. So we would notify other federal agencies, FEMA, the State Department, and then go from there. And it is scenario dependent. It depends on what the characterization of the asteroid or the NEO happens to be. Sometimes it's just a matter of saying, hey, we now have something else that has been added to the inventory. It's not in an Earth-threatening orbit, and we do that.
Could you talk about whether there is an organized international warning network, or should there be? Is this something that's, again, scenario dependent, or is there an actual formal network?
Dr. Holdren mentioned the recent meeting in conjunction with UN COPUOS that actually the chair was an American, a NASA scientist, and from that meeting came the initial decision that we would organize, and I can get you more information on what they propose, because like everything else, it's a proposal for an international collaborative effort to do this.
If I could just add one thing to that. The Minor Planet Center, which I mentioned before, which is located at the Harvard-Smithsonian Astrophysical Observatory, is a formal international entity to which everybody automatically feeds discoveries of new near-Earth objects. So there is already a formal network which functions to assemble all the information that's available from all these different telescopes around the world, and even the amateur astronomers know where to go with their findings. They go straight to the Minor Planet Center, and the Minor Planet Center then goes to the NASA operation at JPL, which is responsible for working out the trajectory in coordination with these other groups. But the thing that is new, the International Asteroid Warning Network, which emerged from this February 15th meeting in Vienna, will ramp up this whole effort and will add, I think, additional layers of capability as countries come together to say, given these current scattered assets, what more do we need and how do we get it?
It seems to me that's very important for several reasons. Everybody's under budget constraints, so that we should be more effectively deploying world resources in this range. But also confidence building, which I worry about from a security point of view, that if other countries see this as threatening because we might use these technologies in some other way, it's going to be vitally important that we are sharing in a way that in fact respects the assets other countries have, and we all get the benefit for worldwide resources. So if you have specific proposals as the outcome of the Vienna conference goes forward, I hope you'll come back to us to help us bring those forward to leadership about new opportunities, but in fact will be life-saving and planet-saving potentially, but that will require greater collaboration. Thank you very much.
Thank you. Thank you, Ms. Esty. The gentleman from Texas, Mr. Weber, is recognized.
Thank you, Mr. Chairman. Mr. Holdren, you said that the asteroid that hit Siberia was 15 megatons. What was the name of that event?
That was
Tunguska.
Tunguska. Yeah.
Okay. And then you said, I think y'all agreed there was 13,000 objects.
13 to 20,000, 140 meters and above. So the number would be somewhat larger for asteroids 100 meters and above.
How close is the nearest one?
Well, it's not a question of how close it is now. The question is how close will its orbit take it to the Earth in the near future. Right now, as Administrator Bolden has said, none of these asteroids that we have found is on a collision course with the Earth.
Okay. You also, well, I think it was you, General Bolden, that said Russia meteor was hidden by the sun. It's the reason we didn't detect it, because it came straight out of the sun.
I wasn't, but that is correct. The folk in NASA, when I asked the question of how did this happen, it came from
My
out of the
question is,
sun.
when something comes right out of the sun directly at us, at some point we're able to identify it. General Shelton, you said, how much time do we have? Is that 10 minutes, 2 hours? At what point does it become identifiable as it gets to the Earth's atmosphere?
Well, one thing, Congressman, I do have to reemphasize, we talk about these 3-week scenarios. That is so unlikely, and even the occurrence in Russia, that was not a city threatening. If you were in Russia, that was a significant event, but that is not of the size that is the city threatening, the region threatening, the other kind of threat.
Can you give me a time frame on how long we would have when one actually is in the...
It is my belief that we can identify in sufficient advance those that are the big threats, but we need to do better.
Okay. We had the Hubble telescope up for a long time. Now we've replaced that.
Still up.
Still up. And you and I had the discussion in my office. We have a better telescope up.
We're a little ways away. 2018 we'll launch the James Webb Space Telescope, but they're not in the asteroid NEO identifying. They're looking at totally different things. They're looking at.
But given the scenario of low funding and the time being of the essence, could we make that change to where we could add on to that telescope so we get it up in space?
No, sir. Very simply, no, sir.
Can't do that.
No, sir.
Okay, the ISS.
We would not want to do that, to be quite honest. We have a plan right now. Dr. Holdren and I both have mentioned collaboration with private industry, with private organizations like B612. I don't want anybody to think that B612, is going to save the planet, but they are doing what we need to do in terms of providing a means to identify.
That was my question
yes,
about
sir.
that particular telescope. The ISS, if I remember correctly, orbits the Earth every 91 minutes?
That's about right.
How much of a role do they play in being able to identify, and how much time does that?
Right now, we don't utilize it at all, but as I talked about when I was in with you, we are learning every single day that ISS, although we thought it was not a platform that you would want to do Earth science, it is turning out to be a great platform, and we are learning more and more about it. We have a solar experiment that's going up, and there may be the capability to put something there, but that is not going to be the answer.
Buy us 6 hours, 6 days, 6 weeks?
I would not even like to fool anybody that ISS and anything we can put on it is going to answer this question. The types of things that Dr. Holdren mentioned and I mentioned earlier are the way we need to go.
All right, 2 final questions, and I've got to go. Who monitors this screen for all of these objects? Does it ding your iPhone when there's a threat coming? I mean, somebody's got to be watching some instrument 24/7 to say, oops, we picked one up. Who does that?
That happens at the Minor Planet Center, where all the information from all of these sensing instruments around the world goes.
And then final question. So you explode an asteroid. How do we know that we get total disintegration and we don't have, instead of one big object coming at us, 20 very lethal objects? Does that determine the?
You don't know that. That's one of the reasons that blowing one up close to the Earth is not a great option. Deflecting it farther from the Earth so that it doesn't hit us at all is a much better option.
Thank you, Mr. Chairman. I yield back.
Thank you, Mr. Weber. The gentleman from Texas, Mr. Beasley, is recognized.
Thank you. I forgot who it was earlier talked about an asteroid hitting an ocean and causing a tsunami. I guess depending on the size of the asteroid would be the correct answer to this question. But how far inland could a reasonably sized asteroid make water come in? Because that was really interesting to me.
There's a very interesting discussion of exactly that question in Dr. Yeoman's book, and the answer is we really don't know, because the dynamics of tsunamis caused by asteroid impacts are, number one, very complicated and not adequately investigated, and it depends on many factors, including the slope of the ocean bottom close to the continent that's going to be most affected, and it depends on a lot of other characteristics of the asteroid impact. So I think there's no simple answer to that question that we can give at this time.
What about asteroids hitting other, planet systems, or what sort of research do you have on that?
Well, there are a lot of craters out there. There are craters on the moon from asteroid impacts, which we can see very clearly. And one any recent craters on the moon? Yeah, I would have to get back to you on that. I'm not sure what the most recent impact on the moon is, but I think none very recent. But again, in geologic time, recent can be quite a stretch of time. Exactly. But there are also lots of evidence of asteroids bashing into each other. If you look at the larger asteroids that are out there, they themselves are pitted with major craters that come from them bumping into each other.
Thank you.
Thank you, Mr. Beasley. The gentleman from Utah, Mr. Stewart, is recognized.
Thank you, gentlemen, for your time and your. I know you and your careers, and I have a great deal of respect for you. So thank you for that, General Bolden. Good to see you, sir. We spent some time at your place talking the other day, and I know that you are a former Marine pilot. As you know, I'm a former Air Force pilot. My question is actually for General Shelton, as a senior Air Force officer with great wisdom and insight. Is it your understanding, sir, as it is mine, that Air Force pilots are the best pilots in the world?
I'm going to have to say yes on that, sir.
Thank you, sir. I'm surprised no one's asked that question yet. I'm glad I was able to. Actually, sir,
that's fighter pilots of all services with the Air Force. I'm an attack pilot.
You're a bigger man than I am, because I've never landed on a carrier. So, actually, I have a couple of simple questions and maybe a more detailed one. The first would be, we've spent a lot of time talking about detection avoidance, and some of the uncertainties about that. I'm curious about policy, public policy. If we were to determine that there was a threat, and then even determine that it was actually potentially devastating, do we have a policy as to whether we would share that information with the public and how we would do that? And Dr. Holdren, I guess that's probably most appropriate for you.
My expectation would be that we would notify, but the first thing that would happen if information came in indicating that an asteroid had been detected to be on a collision course with the Earth and it was big enough to do serious damage, it would be exactly what happened after the Fukushima earthquake and tsunami affected Japan. Namely, there would be a gathering in the Situation Room within minutes, in which we would have the chairman of the Joint Chiefs of Staff, we'd have the Secretary of State, we'd have the head of FEMA, we'd have the Secretary of Homeland Security, we'd have the head of NASA, we'd have General Shelton, and there would be an intense discussion of the whole range of actions that the government would take in order to deal with the threat, whatever it was. And in that meeting, unquestionably, there would be a discussion of who to notify, how fast, in what form.
Yeah, and I understand that. I'm more curious, and I'm not advocating one way or the other. I'm just curious. Have you determined the protocol for advising the public? Is that part of that matrix?
I don't know whether FEMA, which would have that responsibility, has developed a formal protocol. We could get back to you on that.
Okay, I wish you would. I'd be curious to know that. And the second thing, and we've all talked about it. Maybe I'm just not that bright. I'm not sure I get it, but. The saying, we don't know what we don't know, and you said that we've discovered 94% of the asteroids over 1 kilometer, for example. But if we don't know what's out there, how do we know that we've discovered 94% of them?
That's actually a very good question, and it turns out that there are subtle statistical techniques that rely on sampling of subpopulations and what fraction of them you've seen before in order to determine what fraction of the overall population you've actually seen. That is actually described again in wonderfully clear detail in Dr. Yeoman's book. It was the best explanation of that I've seen.
So you're interpolating there. You're drawing conclusions, but you're fairly comfortable.
You're drawing conclusions based on sampling.
Right, but you're fairly comfortable with those figures.
Yes.
Okay. And then the last question in the minute or so I have left, we talk about detection being, the first line of defense and our efforts, and you've mentioned some of the others as well. But, is the United States the lead on this? Clearly we are, but are other nations contributing to this detection effort in a meaningful way? Or is it almost entirely our efforts that are meaningful here?
No, absolutely other nations are contributing in a meaningful way. There are important telescopes and data centers in Italy. That's a German-Italian collaboration. There's another one in Czechoslovakia. There are some, the LSST will be in Chile. There are some in Australia. And again, this domain is actually remarkable for the degree of international cooperation and interconnection compared to many others where we are not nearly as far along.
As it should be, of course, because we all got a dog in this fight. So those other entities, are they funded by the EU and other? They're not with American funding at all. Those are entirely independently funded efforts.
No, they're not entirely independently funded. For example, the Large Synoptic Survey Telescope is being very substantially funded by NSF, even though it's going to be in Chile.
Yeah.
But of course it will be an NSF facility in a sense. The Arecibo Radio Telescope in Puerto Rico is funded by NSF.
Right. So even though these are geographically located around the world, they're primarily U.S. efforts.
I would have to get back to you on the international distribution of the funding. Okay. Certainly there's substantial funding from the European Space Agency. There's substantial funding from Germany, from Italy, from Czechoslovakia, from France, but I could not give you a percentage.
Again, if you would, I'd appreciate that. Thank you. And Mr. Chairman, I yield back. Thank you.
Thank you, Mr. Stewart. The gentleman from Florida, Mr. Grayson, is recognized.
Thank you, Mr. Chairman. Gentlemen, we could spend each year $1 million on space threats. We could spend $1 billion, or we could spend $1 trillion. I'd like to hear from each one of you what we should spend. That's what we have to decide here. And specifically, I'd like to hear either a number or a formula. I think with the Science Committee can deal with formulas, or some sort of list of the things that you think must be done without regard to what they cost. Let's start with you, Dr. Holdren.
The National Academy of Sciences just a couple of years ago came out with a report in which they actually addressed this question. And they looked at what you could do for $500 million a year, what you could do for $100 million a year, what you could do for 50. I would say on the basis of that, if we are just looking primarily at detection and characterization, that I think we would want to be spending upwards of $100 million a year. If we are looking, as I think we must as well, at mitigation, then you would have to include the costs of carrying out the President's goal of visiting an asteroid by 2025. Various estimates have been put forward of the cost of doing that, but it almost certainly would be in the range of $2 billion or more spread over the period between now and 2025.
Thank you. General Shelton.
Yes, sir. In my case, we're talking about geosynchronous orbit into the surface of the planet. So just that part of space that we are responsible for, probably 200 or 300 million a year-ish, is what we're talking about, developing better sensors that are more sensitive to the space debris population that is growing, sensors that allow us to take better, to better catalog the activity that's there and characterize it. As threats continue to grow in space, both adversarial threats as well as environmental threats, we need to be able to characterize that much better than we have the capability to do today. So I'd say that 200 to 300 million range is what we're talking about.
Good. Administrator Bolden?
Sir, the only thing I will add, because Dr. Holdren pretty much answered it there, is I want to reemphasize, because we have identified 95% of those objects that are a kilometer and above, and we have seen none that are on a collision trajectory with Earth, this is not an issue that we should worry about in the near term. However, as I said, the President has laid out a plan, and I would say that's a very good start. We have a lot of work to do, but the funding that is presently laid out in the President's budget is sufficient to get us there incrementally. We just have to move that plan forward. So you can't stop. That's my point.
All right. Now, tell us what kind of costs we would be facing if we spent nothing. It can be a worst-case scenario or a not-so-bad case scenario, but just the likely costs we'd face if we did nothing. Let's start with you, Dr. Holdren.
This is a very tough question because there are different ways to present these things. If you take the expected value of the damage in terms of loss of human life, integrated over a very long period of time, it comes out that the estimated loss of life from asteroid impacts is only about 100 per year. That compares with 1 million per year for malaria. It compares with 5 million per year for tobacco. So it doesn't look like a very big threat. But of course, that is not really a meaningful way to present a risk of this character, where you're talking about a low probability of a very big disaster. And in those sorts of situations, we tend to invest in insurance to reduce the likelihood of a disaster we would regard as intolerable. If you say, how big is the disaster? If you're talking about a 10-kilometer asteroid of the sort that exterminated the dinosaurs, what is the value of all of civilization? It's a very big number, but is it meaningful as a number which you then divide by the 65 million year return time? I think we just can't get at it that way.
General Shelton, the cost of a worst-case scenario.
Well, again, from a DoD perspective, we would not be able to characterize the traffic on orbit. We would not be able to avoid collisions on orbit. We would not be able to detect adversary activity on orbit. And our dependence on space, by the way, not only for our way of life, but also for military operations, is very high. So we would sacrifice that.
Thank you, Mr. Chairman.
Thank you, Mr. Grayson. And let me thank our witnesses today for their testimony. This has been a particularly interesting hearing. No doubt there'll be some follow-up questions that will be addressed to you all. But thank you for being here, and thank you for your expertise as well. We stand adjourned.